Hello, good morning, friends. I hope you all are fine. So, in today's class, we will determine the water content of soil sample using different methods. So, I'm sharing the screen. I hope it is visible to you. So, the aim of this experiment is determination of water content of soil solids by oven drying method. In the first method, we will determine the water content of soil solids by oven drying method. So the water content of a soil sample is equal to mass of water divided by mass of solids. It is how we are defining water content of soil sample. Water content of soil sample is equal to mass of water. How much mass of water is present? MW divided by mass of solid, MS. So which specification is used for performing this test? This test is done as per IS 2720 Part 2 1973. So the IS code used for this test is IS 2720 Part 2 1973. The soil specimen should be representative of soil mass. So this test is done as per IS 2720 Part 3 1973. The soil specimen should be representative of the soil mass. The quantity of specimen taken would depend upon the gradation of the maximum size of particles. For more than 90% of the particles passing through 4.25 micron ISU, the minimum quantity is 25 gram. So how this test is performed? This test is performed as per IS 2720 Part 2 1973. The soil specimen should be representative of the soil mass. The quantity of specimen taken would depend upon the gradation and the maximum size of particle. For more than 90% of the particles passing through 425 micron ISU, the minimum quantity is 25 gram. So what are the equipments required? Non-portable airtight containers. Next, balance weighing to accuracy 0.04% of the weight of the soil taken for the test. Desiccators with suitable desiccating agent. Thermostatically control oven to maintain temperature 110 degrees Celsius to plus or minus 5 degrees Celsius. Other accessories. So the theory part includes what is the theory part includes in almost all tests, natural moisture content of the soil is to be determined. The knowledge of the natural moisture content is essential in all the studies of soil mechanics. To cite a few, natural moisture content is used in determining the bearing capacity and settlement. The natural moisture content will give an idea of the state of the soil in the field. Water content W of a soil mass is defined as a ratio of mass of water to in the voids to the mass of solids. So how we are calculating water content? W2 minus W3 divided by W3 minus W1 percentage. So where W1 is weight of empty container in grams, W2 is weight of container plus wet soil in grams, W3 weight of container plus dry soil in grams. Precautions. Ensure that the soil samples are between 350 gram to 400 gram. Larger samples take too long to dry, while smaller samples lead to inaccurate results. Ensure that the oven temperature is maintained at 110 degrees Celsius plus or minus 5 degrees Celsius. Do not allow the oven door to open. Stay. See, what are the precautions? First precaution is you have to ensure that the soil samples are between 350 to 400 gram. Large samples take too long to dry. While smaller samples lead to inaccurate result. Neither you can take less quantity of soil sample nor you can take more quantity of soil samples. The thing is that what you have to do, you have to ensure that the soil samples are between 350 to 400 gram. Larger samples take too long to dry while smaller samples lead to inaccuracy. Ensure that the oven temperature is maintained at 110 degrees Celsius plus or minus 5 degrees. Do not allow the oven door to stay open for too long. as it takes a while for the oven to regain the drying temperature. Do not put moist samples in the oven on a shelf below dry sample. Moist sample should be placed on the top shelf and a partially dried sample placed on the lower shelf. Do not overload the oven as this will create much longer drying time. Do not allow dried samples to pick up moisture after they are removed from the oven. Weigh them immediately after drying. Soil and aggregates may contain bacteria and organisms which can be harmful for oneself. Wearing dust masks and protective gloves when handling materials is well. The use of heat-resistant gloves, mitts, or pot holders to remove samples from the oven is recommended. Prior to handling oven, testing, or disposing of any waste material, students are required to read do's and don'ts of the geotechnical engineering laboratory procedure. Clean the container with lid and find the mass W1 gram. First step is you have to clean the container with the lid and find its mass that will be W1 gram. Select the required quantity of moist soil sample, place in the container, place the lid on it and weigh it, that will be W2 gram. Second step is you have to select the required quantity of moist soil sample. So quantity of soil sample is not defined here. In the earlier experiment, 30 gram, 25 gram, it was clearly stated. But in this experiment, depending upon unit, you can take the soil sample. Keep the container in the oven with lid removed and dry it for at least 24 hours. So for drying the soil sample, you are keeping it in the oven, but lid should be removed while keeping in the oven. And the temperature of the oven is 110 degrees Celsius till the mass remains constant. Remove the container from the oven, replace the lid and cool it in a desiccator. Find the mass W3 gram. After drying the soil sample in the oven, what you have to do, you have to cool it in a desiccator. That will be W3 gram. Then determine the water content W by using the above equation. So repeat the experiment with other test samples. So water content is also called moisture content. Which method is most suitable? Till now only we have studied this method only, so it looks suitable to us. What is water content for clay soil? It depends. Different clay will have different water content. On which factor water content is dependent? Water content is dependent on type of soil, type of desiccators used, oven used, different parameters it depends. Ground penetrating radar method is also used for measuring water content. False. False. Name different types of soil textures. Flocculent structure, dispersed structures, monocollant structure, element structure, dispersed structure, different types of structures are there. The percentage of water remaining in an air dry soil is called percentage air. So weight of container tabular column, weight of empty container that will be W1 gram, weight of container plus wet soil W2 gram, weight of container plus dry soil W3 gram, water content is W1 W plus W2 plus W3 by 3. Specimen calculation. So what is W1, W2 and W3? That is important. Compared to earlier experiment of specific gravity, in this method of determining water content, W4 is not there. Only three, W1, W2, and W3 is there. W1 is same weight of empty container. W2 is weight of container plus wet soil. In the next experiment, it was dry soil. Here it is wet soil. W3 is weight of container plus dry soil. So here W water content is equal to W2 minus W3 divided by W3 minus W1 into 100 because water content is expressed in terms of percentage. Average Daily is this one. Verification or validation. Soil mass is generally a three-phase system. It consists of solid particles, liquid, and gas. The phase system may be expressed in SI units either in terms of mass volume or weight volume relationship. Water content value is 0% for dry soil and its magnitude can exceed 100%. Okay. So conclusion. The experiment is conducted as per the procedure laid down. The water content of the soil mass is determined. Water content W equal to percentage. The value is verified and three-phase system is checked. Draw the schematic diagram of three-phase system based on the result. So that you can do diagram. Is there any possibility of the soil getting burnt? In that case, what will be the effect on water content? The water content value will change. It will decrease suddenly. How does air dried soil sample differ from oven dry? In air dried sample, the environment is open to atmosphere, so it will have an adverse effect. Whereas in own dry sample, the environment is closed in an oven. Is this method the most accurate method to determine water content of soil? Just now we have studied the first method. Let us see the different method first. To get accurate, how much gram of soil you take and let us see here. It depends. Either you should take less amount of soil, now that you have to take more amount of soil. It depends. Determination of water content of soil solids by pyranometer. Aim to determine the water content of soil solid by pyranometer bottle method. To determine the water content by this method, the value of G should have been determined prior. This test is done as per IS 2720 Part 3 1973. I am sharing the screen. Hope it is visible to you. So this test is done as per IS 2720 Part 2 1973. The method is suitable for score grain soil from which entrapment can be easily removed. Equipment is required. Pyranometer of 1000 ml capacity with a brass conical cap. Balance accurate to 1 gram. Glass rod. Other accessories. Theory. A pyranometer is a glass jar of about 1 liter capacity fitted with a brass conical cap by means of a screw type cover. The cap is a small hole of about 600 mm diameter at its apex. For many soils, the water content may be extremely important index used for establishing the relationship between the way the soil behaves and its property. The consistency of a fine grained soil largely depends on its water content. The water content is also used in expressing the phase relationship of air, water, and solids in a given volume of soil. So the water content W of soil mass is defined as ratio of mass of water in the voids to the mass of solids. So your water content W percentage is W2 minus W1 divided by W3 minus W4 into G minus 1 divided by G minus 1 into 100. Where W1 is the weight of empty pyranometer in grams. W2 is weight of pyranometer plus wet soil in grams. W3 is weight of pyranometer plus dry soil in mass. W4 weight of pyranometer plus water in grams. So here additional W4 is there in pyranometer method. So the procedure is clean and dry the pyranometer and weigh it W1 gram. That is what you can say correct only. Clean the and dry the pyranometer weigh W1 gram. Select a mass of wet soil of about 300 gram and place the same in pyranometer and weigh it that will be W2 gram. First is you have to clean and dry the pyranometer and weigh it that will be W1 gram. Next is select a mass of wet soil of about 300 gram and place the same in the pyranometer and weight that will be W2 gram. Next, fill the pyranometer with the distilled water up to half its height and stir the mix with the glass rod. Keep on adding water till the mix is flush with the hole in the conical cap. Dry the pyranometer outside and fill the mass. Find the mass W3. So it is somewhat confusing. You say it carefully. W1 is clearly is not about W1. Clean and dry the pyranometer and weight that will be W1 gram. Select the mass of wet soil of about 300 gram and place the same in pyranometer and weight that will be W2 gram. Fill the pyranometer with the distilled water up to half its height and stir the mix with the glass rod. Keep on adding more water till the mix is flush with the hole in the conical cap. Dry the pyranometer outside and fill the max W3 gram. The W1 is simple, that is empty weight of pyranometer. W2 is 300 gram of wet soil and pyranometer that will be W2. Next is pyranometer with dry soil. In the fourth step, remove the contents of the pyranometer and clean it. Fill with completely with the W4. Now use the above equation for determining water content where G value is taken from experiment 1. See here, W1, W2, W3, W4 is always there whenever you use pyranometer method. W1 is same empty weight of pyranometer with lead. W2 is weight of pyranometer plus wet soil. Whereas W3 is weight of pyranometer plus dry soil. W4 is pyranometer completely filled with water only. G value you can take from experiment 1. So pre-viva question. A pyranometer is used to determine specific gravity as well as water content. Other than pyranometer, is there any method to determine water content? Yes. Sandbart method is there. Bone drying method is there. Which method is more accurate? That to be seen. If there are lots of plots in there, what would happen to the result? There will be error in the result. Is it as well a lot of arguments? No. Explain the procedure, determine water content. Just now we have explained it. Once again, I am telling you, you just see it. First, what you have to do, you have to take empty weight of pyranometer with lead. After that, you have to add 300 gram of soil. So that will be W2. Weight of 300 gram soil sample, wet sample plus pyranometer, that will be W2. After that, you have to take the soil out and it has to be oven dried. And again, it is to be completely filled with water, that will be W3 gram. After that, what you have to do? After that, you have to do is explain the explain the procedure to determine the water content using pyranometer. W4 is empty weight of pyranometer filled with water. So the equation G value you can take from the experiment 1. So how you calculate water content? W2 minus W1 divided by W3 minus W1 into G minus 1 divided by G minus 1 into 100. So average of three readings W equal to W1 plus W plus W3 you have to do divided by 3 will give you the average water content. Validation and verification. Soil mass is generally a three-phase system. It consists of solid particles, liquid, and gas. Soil is a three-phase system, has solid particles, liquid, and gas. The phase system may be expressed in SI units, either in terms of mass volume or weight volume relationship. Water content value is 0% relation and magnetic cancel 100%. So what is the conclusion? Pyranometer method is simple method to determine the water content of soil. Experiment is carried out using the soil specimen collected from the college itself. All foreign matters are removed, clods broken, and water content. We got the soil specimen is comparing with the oven drying method. The value is draw the symmetric diagram of three-phase system based on the result that you can be drawn. Is there any possibility error? Yes. Due to clots in the soil, there may be error. Which method gives the water content rapidly? Pyranometer method or oven drying method? Pyranometer method gives result accurately or very early. Next is examination of fluid movement by core cutter method. This method is used to determine liquid limit. Sorry. No, in-situ density by core cutter method. So to determine the field density or unit weight by core cutter method. So what is field density? Field density is used in calculating the stress in the soil due to its overburden pressure. Field density किस लिए यूज करते हैं हम? To calculate the stress in the soil due to its overburden pressure. सॉइल के ऊपर ओवरबर्डन प्रेशर होने की वजह से स्ट्रेस डेवलप होते हैं. इसको ये करने के लिए हम क्या मालूम करते हैं? फील्ड डेंसिटी. It is needed in estimating the bearing capacity of soil foundation system, settlement of footing, earth pressure behind the retaining walls and embankment. किस लिए यूज होता है ये field density? It is used in estimating the bearing capacity of soil foundation system, settlement of footing, earth pressure behind the retaining walls and embankment. Stability of natural slopes, dams, embankments, and cuts is checked with the help of density of soil. If the density that controls the field compaction soil, permeability of soil depend upon its density. Permeability of soil depend upon its density. Relative density of cohesionless soil is determined by knowing the dry density of soil. In natural, loosest and densest state, White's ratio, porosity, and degree of saturation need the help of density of soil. So specification, what is the specification? This test is done to determine the in-situ dry density of soil by core cutter method as per IS 2720 part 29 1975. Core cutter method in particular is suitable for soft to medium cohesive soil in which the core cutter can be driven. It is not possible to drive the cutter into hard and boulder soils. Equipments required. Cylindrical core cutter, 100 mm internal diameter and 130 mm long. Steel dolly, 25 mm high, 100 mm internal diameter. Steel rammer, mass 9 kg. Overall length with the foot and stuff over 900 mm. Balance with an accuracy of 1 gram. Pellet knife, straight edge, steel rule, etc. Square metal tray, 300 into 300 into 40 mm. Rower. Area. Field density is defined as weight per unit volume of soil mass in the field at in-situ conditions. In the spot adjacent to that where the field density by sand equipment has been determined or planned, drive the core cutter using the dolly over the core cutter. Stop ramming when the dolly is just proud of the surface. Dig out the cutter containing the soil out of the ground and trim off any solid excluding plants so that the cutter contains a volume of soil equals to the internal volume which is determined from the dimensions of the cutter. The weight of the contained soil is found and the moisture content determined. So equations required is gamma d rho d is equal to rho t divided by 1 plus w gram per centimeter cube or gamma d is equal to gamma t by 1 plus w kilonewton per meter cube where rho d is the dry density in gram per centimeter cube, rho d is the dry unit weight in gram per centimeter cube, rho t is the field moist density in gram per centimeter cube, gamma t is field moist unit weight in gram per centimeter cube, W is water content percentage, gamma W is unit weight of water equal to 9.181 kilonewton per meter cube. Precautions. So what are the precautions you need to take during this test? Core cutter method of determining the field and soil is only suitable for fine grained soil, silts and clay के वास्ते suitable है. This method is not suitable for gravels, boulders or any hard surface. This is because collection of undisturbed sample from a coarse gradation is difficult. Hence, the field properties including unit weight cannot be maintained in coarse sample. ये जो core cutter method है, it is suitable only for fine grained soil, silt and clay के वास्ते. Coarse grains के वास्ते suitable नहीं है. Core cutter should be driven into the ground till the steel dolly penetrates into the ground halfway, only so as to avoid compaction of the soil in the core. Next step में क्या कर रहे हैं? Core cutter should be driven into the ground till the steel dolly penetrates into the ground halfway only so as to avoid compaction of the soil in the core. आदत जाना डॉली अंदर. Before lifting the core cutter, soil around the cutter should be removed and minimize disturbance. Before lifting the core cutter को ऊपर उठाने से पहले आजू बाजू की soil remove कर लेना. While lifting the core cutter, no soil should drop down. Core cutter उठाते हैं soil ये नहीं होना गिरना नहीं. Procedure: measure the height and internal diameter of core cutter to the nearest 0.25 mm. हाइट और लेंथ मालूम कर लेना. हाइट और डायमीटर मालूम कर लेना कोर कटर का. कैलकुलेट द इंटरनल वॉल्यूम ऑफ द कोर कटर वीसी इन सेंटीमीटर क्यूब. इंटरनल वॉल्यूम भी मालूम कर लेना कोर कटर का वीसी इन सेंटीमीटर क्यूब. डिटरमाइन द वेट ऑफ द क्लीन कोर कटर एक्यूरेट टू 1 ग्राम. वेट मालूम कर लेना क्लीन कोर कटर का 1 ग्राम. सेलेक्ट एन एरिया इन द फील्ड वेयर द डेंसिटी इज रिक्वायर्ड टू बी फाउंड आउट. एक अच्छा सा एरिया ढूंढ लेना जहाँ पे आपको टेस्ट करना है. प्लेस द डॉली ओवर द टॉप and the core cutter and press the core cutter into the soil mass. Next step is what you have to do is place the dolly over the top of the core cutter and press the core cutter into the soil mass using a hammer. Stop the pressing when about 15 mm of the dolly protected by the soil support. 15 mm dolly at the प्रोड्यूस करते हैं. Remove the soil surrounding the core cutter by digging using spade up to the bottom level of the cutter. Soil के आजू बाजू को हिस्सा साफ कर लेना. Lift up the cutter and remove the dolly and trim both sides. Remove the soil surrounding the core cutter by digging your spade up to the bottom level of the cutter. Lift up the cutter and remove the dolly and trim both sides of the cutter with knife and stagger. Next, clean the outside surface of the cutter and determine mass of cutter with the soil W2 gram. Remove the soil core from the cutter and take the representative samples in the water content to determine the moisture content. The field test may be repeated at other places if required. The water content of sample collected is determined in the laboratory as per experiment number 3. Get a determination of water content of soil soluble water method. Use the above equation given theory section for determining density of soil, gamma D or sigma D. So what are the pre-viva questions? Out of wet density, dry density, and saturated density, which of them is maximum and minimum? So that is a different question that waits in the theory class. What are the main factors which affect density of soil? So the factors that affect density of soil is compaction, shear stress develop, consolidation, load acting on the soil, etc. Beside the density, what other properties do you need to calculate the void ratio degree of saturation of soil? Yes, you need to calculate the void ratio degree of saturation of soil. What are the other methods to determine field density of soil? That we will see further. What is the more recommended to determine the field density? That also you need to see. And the next observation, length of core cutter dash centimeter, diameter of core cutter dash centimeter, volume of core cutter dash centimeter. This you will get from the observation. Weight of core cutter, weight of empty core cutter, that will be W1 gram. Weight of cutter plus wet soil, that will be W2 gram. Volume of core cutter we see in centimeter cube. Weight of mass, weight of empty container W3 gram. Weight of container plus wet soil W4 gram. Weight of container plus dry soil W5 gram. So water content W is equal to W4 minus W5 divided by W5 minus W3. Field moist density routine kilonewton per cube equal to W2 minus W1 divided by VC. Dry density roughly equal to root W. Average density average rho D. Specimen calculation average rho D equal to rho D1 plus rho D2 plus rho D3 by 3. Average in-situ field density this much. Verification or validation. So the dry density of most soil varies with the range of 1.1 to 1.6 gram per centimeter cube. In sandy soils, dry density can be as high as 1.6 gram per centimeter cube. In cloy soils and aggregated loams, it can be as low as 1.1 gram per centimeter cube. So the value of dry density of the soil is this much, and the type of soil is this much. So based on the dry density value, the type of soil can be identified. Post viva question. Can we use core cutter method on stone or non-cohesive soils? No. Which method is more accurate, sand replacement or core cutter method? That needed to be seen because sand replacement method still we have not seen. What is the practical application of current test? This test helps to identify the bearing field density or in-situ density of soil, which is essential for determining the type of soil and also the stresses developed in the soil due to overburden pressure. What do we get an instruction in core cutter? No, only desktop samples we get to see core cutter. Why is field density required? Field density is required to calculate what we can say. Just I will go back. Field density. Why it is needed? Field density is used in calculating the stresses in soil due to its overburden pressure. It is also needed in estimating the bearing capacity of soil foundation system, settlement of footing, earth pressure behind the retaining walls and embankment. The stability of natural slopes, dams, embankments, and cuts is checked with the help of density of soil. It is the density that controls the field compaction of soil. Permeability of soil also depends on density. Relative density of cohesion soil is determined. So all for all this thing we need density. Out of wet density using this post this already we have seen. So determination of in-situ density of sand replacement method we will see in the next class. After that only we will come to a conclusion whether core cutter method is good or whether in-situ density is what you can say core cutter method is good or either this method what you can call oven drying method. Core cutter method is good or sand replacement method. If you have any queries, you can just drop a message in the comment box. You can also contact me at my email ID at nadeem@cable.university, or you can call me at or you can just mail me at nadeem@cable.university. So I hope you're having a good time. So I am ending the meeting here. Have a nice day.